असतो मा सद्गमया तमसो मा ज्योतिर्गमया मृत्योर्मा मृतङ्गमया ॐ शान्ति शान्ति वन्दे मातरम् वन्दे मातरम् सुजलां सुफलां मलयज शीतलां सस्यश्यामलां मातरं वन्दे मातरम् शुभ्रज्योत्स्ना पुलकितयामिनी भुल्लकुसुमिता द्रुमदलशोभिनी सुहासिनी सुमधुरभाषिणी सुखदां वरदां मातरं वन्दे मातरम् वन्दे मातरम्.
Hello everyone, hope you are all having a nice day. First of all, let me wish you all a happy Independence Day. As you know, this is the 76th Independence Day and our country India is celebrating Azadi Ki Amrit Mahotsav. And I feel an intense wave of pride and joy to welcome you all on this special day to our program Math Ecstasy, an Odyssey through Mathematics. So this is a series of national webinars organized by Math Aspirants. And this is our 6th national webinar after 5 successful national webinars. And today we are organizing our webinar on the topic Building a Successful Career with a Mathematics Degree, Opportunities and Challenges by our speaker, Dr. Indira Narayanaswamy. Now let me note a little bit about the organizing team. So Math Aspirants was initially a WhatsApp group started by Dr. Vinod Kumar sir. He is an associate professor of mathematics in TM Government College, Tirur. I know everyone here knows him, just a matter of formal introduction, I'm just telling. And the initial purpose was to discuss mathematics in a creative way and occupying the students with more possibilities and more kind of thinking in mathematics. So slowly, this platform began to grow. The team under Dr. Vinod Kumar sir organized many classes and problem-solving sessions for a lot of exams, which are all national levels. And now it has members who are studying in many premier institutes of India. And I must say, there is an international attention for this informal organization. And in 2020, August 15, there was a milestone happened for Math Aspirants, which is the first national webinar. And I must mention the date. It was on August 15, the Independence Day of 2020. It was a good program. It was a success. And after exact 2 years, I can see how much impact this informal team, the organization has made. Now, if we type Math Aspirants Vinod Kumar, TMG calls it, just Vinod Kumar, you can see in Google, there are a lot of news displayed. I can see news from Asianet, I can see news from Madhrubhumi, even I can see news from Hindu. So this is a proud moment. This is a great moment. Such an informal platform can impact this much. And I'm feeling so happy that I could also be a small part of it. And I cannot finish telling about Math Aspirants without mentioning Dr. Bijumon sir, Assistant Professor, MG College, Iritty. He is working behind so hard that all the technical things are handled by him. And also I would like to remember all other teachers and students who were also part of this team in some event. There were so many events. And I'm really, really so proud and happy to welcome you all to today's national webinar. And I appreciate everyone who is present here, because your love of mathematics is the reason why you are here. And the mathematics is the one thing which make us all one family. That's right. And I appreciate your efforts for being here. And I humbly request you to show your presence throughout the webinar. And that's the best thing you can do. So this is a great moment. And I really, really welcome everyone, each and everyone, especially all the teachers and the most distinguished, our speaker, Dr. Indira Narayanaswamy. We are all very, very happy and very thankful for you, ma'am, for being here. And your talk is so valuable for us, for each of us. And now I would like to welcome Dr. Vinod Kumar, sir, for sharing a few words.
Dear friends, Independence Day greetings to everyone. Hearty welcome to all of you to today's national webinar. As Arjuna mentioned in the beginning, Math Aspirants is a collective of math lovers, students, researchers, and teachers initiated by myself in 2017. After 5 years, Maths Aspirants now became an active discussion platform of higher mathematics with participation from all over India and abroad. I fondly remember all the teachers, friends, students who helped me in my journey with this Math Aspirants. And I would like to express my sincere gratitude and thanks to Professor Indira Narayanaswamy, ma'am, for accepting our invitation and joining with us. Also, I am grateful to Professor Ampal Vijaykumar, sir, for his great support throughout the activities of Maths Aspirants Groups, and in particular for introducing today's resource person to me. And I would like to express my thanks to Aparna ma'am for introducing today's resource person as a part of this webinar. And I express my Miss G.R.O. Johnson, who is a research scholar in IIT Madras, and Miss Anne-Marie Tony, a research scholar in Cochin University of Science and Technology, and Miss Kajal Sachdeva, a research scholar in MD University, Haryana, and also to Miss Arjuna for the vibrant presentation of today's webinar. I'm sure that today's session will be really fruitful to all the participants, and I wish everyone a great academic time ahead. Thank you. Thank you.
It's my great pleasure to welcome Aparna Lakshman, ma'am. She is an associate professor in CUSAT, the college I went for MPhil, and I'm really happy that when I see her, she's always smiling and she's always a happy person. She's the best to introduce our speaker, Indira Narayanaswamy. So welcome, ma'am. Hearty welcome.
First of all, happy Independence Day to one and all gathered here. Let me directly move on to my duty. It's a great privilege for me to introduce Dr. Indira Narayanaswamy. She's born in Madras and had her schooling and undergraduate and postgraduate studies in mathematics from Alleppey, Kerala. I'm happy to add that she was a first rank holder in MSc Mathematics from SD College, Alleppey. She was also recipient of National Science Talent Search Scholarship by NCERT for higher studies in mathematics for UG, PG, and PhD program, securing a first rank at national level. After completing her PhD in mathematics for her thesis entitled Lambda Cardinal Splints, she had her postdoctoral research at University of Pittsburgh, USA, where she worked on smoothing of curves and surfaces using spline functions. After her postdoctoral studies, she joined Aeronautical Development Agency, ADA, at Bangalore, an autonomous body under Ministry of Defense. She had 28 years of long service at ADA and went to superannuation on 30th April 2015. She was Technology Director of Aerodynamics and Performances Directorate for almost 4 years at ADA and had headed many important projects. After 28 years of service in ADA, presently she is working as research professor at MS Raman University of Applied Sciences, India. She had a total experience of more than 33 years of research and teaching. She is also a recipient of VIFRA Lifetime Achievement Award in 2015. I personally had a privilege of meeting her during ICM 2018 at Rio de Janeiro, Brazil. She had written more than 150 technical articles and is a well-sought resource person. With that, I introduce Professor Dr. Indira Narayanaswamy.
Thank you, Aparna ma'am. That was a well-explained academic description about our speaker today. And I'm feeling amazing about the academic history of the speaker we have today. It's so lucky that I am here, and I'm really expecting that everyone here is also feeling the same. So it's time to start the cream part of national webinar we are organizing today. So welcome, Indira ma'am, again.
Okay, thank you, Dr. Vinod Kumar. I think Dr. Vijay Kumar Ambat, who introduced me to Dr. Vinod Kumar, because Dr. Vijay Kumar's association for me with him has been for quite a while. And in fact, I was one of the invited speakers from the Indian Mathematical Society annual conference in 2013, which was at Kakanad. That is the first time I think I met Dr. Vijay Kumar, and 2018 again I met him. I have been in touch with him quite often. Now let me thank Vijay Kumar sir, and then of course Dr. Vinod Kumar, who actually invited me. Arjuna and of course Aparna for a very nice flowery introduction of me. Doesn't matter. Anyway, thank you all so much. So I have not made it very technical, but I have brought in the general job opportunities. What just a B.Sc or an MSc Maths doesn't get you a job very easily. So what more you have to add to your studies so that you are well equipped for a good job in your and climb up the career. And I have also put some slides on how I have used in our aircraft program. As you all know, Tejas is a very prestigious project of the Defense Ministry in India, being the first indigenized fighter aircraft. I was very much involved in the design, one of the designers, and later I was also part of going for flight trials to various Air Force bases in India. It was a very challenging, but it was a grand learning experience. Now, since many of the information that I have might be still classified, I'm just giving you general mathematics behind some of them. That's all. I hope I come to your expectations. So now I will share the screen and start. Okay, I will just, as Aparna read, this is the topic, building a successful career with a degree in mathematics. What are the opportunities, which are something very new, nice opportunities, which are not aware to many of you. I have actually put. And what are the challenges in the sense that with what more you may have to equip yourself with. So we will go. This is roughly the flow. I will give you an introduction and the current status. I was also asked to make some mention about what are the places of learning, basic learning, higher learning, what are the financial assistance for higher learning in mathematics. And then what next after the higher learning and the demand in career, applied mathematics, basically emerging career opportunities in computer science over startup initiatives, what are the labs where you can go for internships. for summer training or winter training and how to prepare for a career in industry. Now, let us start. This is not going to be very heavy on you. I guess mathematics, you know, is a very creative enterprise, captivating the human imagination since ancient times. And as you all know, an indispensable tool for science and engineering. And as we all know, mathematics is the language of science and technology. Nothing happens in science and technology without mathematics. It provides a basic language to understand the world, lends precision to scientific thought, and also a key element in discovery and invention, starting from Newton's explanation to planetary motion, Einstein's relativity, technologies as Google, everywhere. Mathematics is the basis, and everything is built on that. Instead of pure mathematics, it might be application, applied mathematics. Now, very few bachelor programs in India provide the sort of training and interaction with related fields which are required for leading edge work in new technologies. Modern scientific research reveals a great deal of interconnectedness between the various disciplines which are formerly assumed to be separate. Now, what is the link for various disciplines now is basically mathematics. And this trend is accompanied by the need for future engineers and scientists to acquire a deep foundation in mathematics. Now, let us have a peep into the courses in mathematics at various levels. This I will just rush through because I think you must have had some talk recently from Sharanya, right? Regarding the various courses, basic courses, higher education courses, and what are the financial assistance, what are the which are the institutes which offer this. This is what we all would have done, most of us, 3-year B.Sc program, either in full-time or some universities like SV University. So I have just come up to this only. Mathematics is a language of science and technology. As I said, we will look at the various courses. We will just browse through the whole thing because I think you had some other talk where there was a lot of emphasis on what are the various courses that are available and what are the institutes, and what are the financial assistance. But for the sake of completeness, I have put everything here. This is the first one, is the regular one, 3-year B.Sc program. Then you have the 3-year B.Sc honors program by Chennai Mathematical Institute, 3-year BMath program by Indian Statistical Institute. Then IISc offers a 4-year BS program, but BS is by research. And then 5-year MS program, which is an integrated course at IISc, that is 3+2. They don't call it 3+2, generally it is 4+1. Now you can see the screen, right? You can see the screen.
Yeah, yes, ma'am.
Moment, yeah, fine. So next is the master's route. Our regular route and variants are the 5-year integrated program, which is already there for the last so many years, which has been there at the IITs, ISER, NISER, various central universities. Then you also have the 4-year BS program, which is followed by 1 year of training and research, leading to an MS in IISc. This is more research oriented. And then you have the 2-year Math at ISI, which is after the BMath. Then you also have the MPhil program, but I understand that it is almost being suspended by the new educational policy. Then you have the PhD, you have the regular PhD program, which is after BSc and MSc. Then you also have the integrated program, which has been there in IISc also for many years and other IITs also. That is, after graduation, you can directly go for MS or MTech PhD. On the way, though you say integrated PhD, you can pick up an MS en route by completing the credit courses and also giving a viva. And there are many international universities which also offer admission and financial aid besides a tuition waiver. And for that, the requirements are GRE and TOEFL with very good scores, along with excellent recommendation letters, transcripts from the university people, your faculty. And these are the financial assistance. NBHM, KVPY, DST, UGC has, or CSIR has JRF and FSRF and GATE. Now, I will just go through each of them. In the meantime, I just wanted you all to know that KVPY has been there for more than 10+ years. But from this year onwards, they have subsumed with the DST's Inspire, means it has been absorbed into the comprehensive umbrella of Inspire by DST. So there will not be any further aptitude test from this year onwards for KVPY. But those who had cleared the exam and are getting the fellowship will continue to get their fellowship. Then you have the NBHM. I think most of you know about NBHM. And I also know that not many of the students at QSAT with Dr. Vijay Kumar's department have got scholarship under NBHM also for a doctorate or sometimes even for post-graduation. This is set up by the Government of India under the Department of Atomic Energy in 1983 to formulate the policies for development of mathematics, help in establishment, development of mathematical centers, and give financial assistance to research projects and doctoral and postdoctoral students. It is basically an autonomous organization. It has got its own budget, also takes money what is made available to by DAE, Department of Atomic Energy. The objective is to promote the growth of higher mathematics and coordinate various activities for the development of mathematics among the mathematics enthusiasts in the country. They undertake various activities to identify and nurture talent among students. And they also conduct programs to train students. One is a nurture program, which is a 4-year duration. Every batch of students is assigned to a faculty of active research mathematicians. They devise a syllabus and give them the guidance. Of course, the work, the progress, academic performance will be regularly monitored by the faculty for the continuation of the scholarship. Then you also have various UG, PG scholarships, etc. Now, as we said, KVPY, it was started with a lot of enthusiasm by the government for a national program of fellowship in basic sciences, which was initiated by DST to attract exceptionally and talented and highly motivated students for pursuing basic science and research. However, this is subsumed by with DST's Inspire. And the KVPY, plus let me tell you, it is not a very easy exam. It is really hard nut to crack. The 11th or 12th class, you have to give the exam. It is basically based on your 11th and 12th syllabuses. And if you clear the exam and perform well in the interview, you are selected for the payment of for the receipt of the scholarship. You will get in the undergraduation, first and up to the 3rd year, monthly stipend, annual contingency grant also. And for MSc, 4th and 5th year of BMAT, BStat or MSc, you will get a much higher stipend. Annual contingency grant also is given. Now you have the DST Inspire, Innovation in Science Pursuit for Inspired Research. This is a program which is sponsored and again managed by DST to attract science talent to science. Here also the fellowships are given for doctoral studies by a 2-tier selection process. You know why the 2-tier selection process. Initially, the applications will be screened by an internal committee, but later after that, those who are selected will have to appear for an interview for a final selection by an expert committee. The JRF or SRO program under the scheme are called Inspire Fellows, and every year almost 1,000 final offers of Inspire Fellowships are given to the rank holders of various university level examinations in basic and applied sciences. Now, UGC, CSIR, JA or JRF, UGC and CSIR are conducting the NET exam, that is the National Eligibility Test, which is conducted on behalf of UGC. Now, last few years, the exam is conducted by the National Testing Agency to conduct these various entrance examinations in the country for admission and fellowship in higher educational institutions. Even a person after a post-graduation, if you want to get the teaching job in either a college or a university, or admission for PhD, eligibility for assistant professorship, we have to clear the NET exam, which is conducted by NTA. The amounts are like this: 31,000 for the first 2 years and a contingency grant of 20,000 per year per fellow. At the end of 2 years, the JRF, as a fellow registered for PhD, it will be upgraded to SRF, and stipend becomes 35,000 per month for the third and subsequent years. This is based on the assessment of the research progress and consistent performance and achievements, which are actually evaluated by an expert committee. And the CSIR research fellows are also given medical facility, that means medical reimbursement, as per the central or state government norms. But unlike the state or central government, it is only for the individual. It is not extended to the family. And the most important, though you are getting 35,000 as an SRF, the stipend is exempted from the payment of income tax. Now, GATE exam. I think all of you know about the GATE exam. It is conducted mainly for the postgraduate admission in engineering, different branches of engineering, by various IITs on behalf of the National Coordination Board. And here also, the most qualifying in GATE has become a mandatory requirement to seek admission or financial assistance to postgraduate programs, as also government scholarship, which is subject to the criteria. The GATE score is used by not only Indian, some foreign universities also for admission. Once you give the GATE score, the score is valid for 3 years. Now, what to do after higher studies in mathematics? When I say higher studies, I mean a post-graduation. How easy or difficult it is to have a career in research and teaching. That is the normal procedure. That is a well-trodden path. That is a joining any college or a university as a faculty, and a career in teaching, and where you can continue your research over a period of time. You will also get students to work as a work under you, where you will be the supervisor. It is a very career-wise very rewarding. However, only a very small fraction of people, undergraduates with mathematics major, can be accommodated into once they do their post-graduation or even PhD. Not all of them are lucky enough to get into academics in colleges, universities, or any highly reputed institute like this as a tenured faculty. Now, you also have ICERs, which are also established to integrate and promote interdisciplinary science education and research. They have been successfully attracting talented young minds. Now, we find that ICER also has a same entrance exam like IITs. And what are the other options beyond research and teaching? What I told you right now is all about academics. You do academics, do BA undergraduation, post-graduation, or after a doctoral program also. All of us, most of all will not be lucky enough or may not be even interested in a teaching position. Now, what else? What are the other options? Other options beyond research and teaching. Now, the main thing is the mindsets that we have. There is a great reluctance to go into corporate world among mathematicians because they think it is a non-mathematical job. That is the whole problem. It is our mindsets. When you look at the opportunities, you know, these are also equally rewarding. We do not realize the value of mathematics degree. The demand of mathematics experts has grown exponentially in many careers. And why people are interested in mathematicians is this: they have very strongly developed logical skills, decomposition skills, critical thinking, and most important, problem solving skills. Mathematicians are very organized and they can more easily attack even a big picture problems. So the mathematics career will require a lot of collaboration with other disciplines to find solutions to technological and mathematical problems. Now you see why people are actually keen to have mathematicians, because of the special capabilities which are inbuilt in them. Critical thinking and very logical skills, problem solving skills, and capability to understand and attack a big picture problem. Now let us look at the current in demand careers. These are some of the important ones: actuary, economist, statistician. It is actually pay-wise also, it is very attractive. The most promising career paths based on income level, value addition, and also job satisfaction. Now, I am not sure whether many of you have heard about actuarial mathematics. It is actually used in insurance. How it is used, we will see. application of probability and statistics to assess the risk in insurance, finance, and other industries and professions. Specific job duties of actuarial mathematician includes compiling and analyzing statistical data, creating strategies that minimize the risk, drafting reports which outline the implications of their research, and explaining the results to the stakeholders. The professions in demand are actuary and risk analyst, and there are some institutes where you become professional bodies where people can become the members also. Now, what are the kind of study? These are some simple examples I am showing you. When a person takes the insurance, how do they calculate? They take into consideration not only the age of the person, not only the illnesses he already has, there are many other things. What are the chances of that person being killed in a car accident? What is the cost of treating a cancer patient on an yearly basis? When companies need numbers crunched to determine the probability of events like death, sickness, accidents, natural disasters, retirement, etc., to predict the risk, they need these actuarial science. To get the professional status, they should also do a graduated certification process. First, they should become an associate, then a fellowship credential. And there are the many recruiters in India. Their areas are financial theory, statistical analysis, and the recruiters are ICA Prudential, United India Insurance, just a name, and many of these current private insurance firms. They all are in need of actuarial science. Now, it will be interesting for you all to know in US, if you see other than the engineers, among the mathematicians, the people who make the maximum money are the actuarial science people who are a background in mathematics, because there everything works on insurance. All calculations, everything is done by this actuarial science people who have a very good background in mathematics and statistics. Now, economists, they study the problem in the economy and put forward proposals to solve them. They research on economic issues using mathematical and statistical techniques and analyze financial data and advise organizations accordingly. A few of them even specialize in the formulation of mathematical models towards analysis and solution, have their research published in industry journal. In this case, what happens, very often if the person himself or herself is not a specialist in mathematical economics, they collaborate with a faculty in the Department of Economics, and whatever problems they have, the mathematician who also has a good background of statistics, they enable them to formulate the mathematical model, then do the analysis and solution. And these results are highly appreciated because it is an interdisciplinary between mathematics and economics. And these papers are very often published in highly rated industry journals. Now, this is mathematician. As you know, we all do, when you do B.Sc mathematics, I don't know the currently, but earlier statistics was a compulsory ancillary minor paper. So we all have done statistics. And statistics is also a thorough knowledge of mathematics, and statistics will be very useful in different fields of job offers. Statistical techniques are used to solve business, science, engineering problems by using the appropriate data points from the experiments. You can conduct a poll, you can conduct a survey, you gather the information and develop a statistical model, which is then used to analyze, interpret the information to make decisions and prepare reports, which explains the calculation to come to some rational conclusion. In fact, quite often when the findings are new, they even develop statistical theory in response to business challenges. Now, how do you use mathematics, applications of mathematics in science? What we saw were other fields, science, engineering, business, and industry. Now, in science, we would have never thought how it is used in some of the sciences that I am going to talk about. These are professions in demand. Forensic analyst. Forensic science is a branch of science which analyzes the crime scene evidence in a court of law. One of the main things that crime scene investigators do is collect the data, measure, and document the evidence. This is very highly needed for the forensic scientists to perform calculations and determine the facts of the crime. They should be very well educated in mathematical concepts that they use to analyze the evidence that they capture from the crime scenes. Mathematics makes it possible to show proof of what would have occurred in a crime in data and numbers. This is our job to give it to the forensic scientist. And forensic analysis is generally, as you all know, done by who have specialized chemistry people who have done a post-graduation or specialized in forensic chemistry, which is a very highly demand job, because most of the accidents and unexpected death, untimely death, so many, all those things, when you do, when forensics labs take care, the forensics labs do the analysis. It is the forensic chemistry people who actually do that. Now, forensic scientists, they use not only the measurements that we give, but also proportions in their analysis. When I say proportion, what comes to your mind is trigonometry, is it not? Proportion is basically a ratio. Trigonometry, we know sin alpha, cos alpha, tan alpha. That is very often when they find 2 or 3 points distributed, what they do is you take the points and see whether they are able to get proportion in terms of the trigonometric functions. Hence, trigonometry is also used commonly in forensic science. Probability is a measurement of the likelihood that a specific event will occur under certain conditions. It is forensic scientists often use probabilities to explain how likely it is that their findings are correct, depending on the level value of the probability that they have calculated. Explaining the findings to jury using probabilities is a common method in forensic science. So it is actually taking you to the court of law. The forensic scientist in any discipline needs a very strong educational background in mathematics in coming years. Now, a climate analyst. What is a model of a climate? A simplified representation of the atmosphere of the earth, the land, the oceans, ice, and how these change or interact with each other over time scales. And we do a very simple model. Model will be based on physical laws and uses real observations. Based on the model, using the already known real observations, we try to make predictions. Because we are making a simplified model, it is computationally efficient and provides useful, precise, and accurate results. Now, how do you make the model? What are the variables in the model? The radiation, temperature, speed of the wind. When you say speed, you are in 3-dimensional, right? So the velocity will have 3 components along the 3 axes of coordinates, u, v, and w. Axis x, y, z, they are generally represented as u, v, w. Then what is the pressure, the density, liquid water, ice, radioactive gases. These are some of the important variables in the model. How do you do the modeling and equate these variables? They are used by laws of conservation laws, that is ordinary differential equations and partial differential equations. And they are using laws of conservation, equations of continuity, energy, momentum, and chemical continuity, which actually come in applied mathematics. And as you know, these equations are not simple. It is not possible for us to, it is not like a variable separable or any such simple form or Bernoulli's type of differential equation for which we can get a closed form solution once you are given a boundary initial condition. It is not possible for us to obtain analytic or closed form solution. So what we have to do is only get approximate solution. That means you have to discretize the equations in time and space. We will come into discretization in a later slide. Now, in numerical solution, what are the things that you need? Speed of information, stability of the system, and precision. So what we do is, in order to save time, and as long as you are computationally efficient, you want it to be efficient, as we said, we go for simplified 2D and 1D models. When you go to 3D models, the computation becomes highly intensive. And to address uncertainty, your results of models, what you do is take the given data, do the modeling, and what is the purpose of the modeling? Any other data you put, you should be able to predict. So what you do is use your own data to check the accuracy. When you put your own input data into the model, are you getting the same output for the same inputs? That is one way to address the uncertainty and the accuracy. Now, population ecology. Strategic models are there based on empirical formula, and they use computer simulations. The dynamical models involve ordinary differential equations. Generally, they use stochastic differential equations, difference equations, integral equation, diffusion reaction equations, etc. Here they use postulates about the ecological mechanisms, and these predictions, these dynamic models do not predict as good as the strategic models. Strategic models will be very precise because you are using empirical formula which has been developed by some mathematicians so many years back, whereas in dynamic model you are trying to build a model, and hence it is an approximate model. You don't have a empirical formula which is actually a closed form solution. So you are going to get an approximate solution. So it will do not predict as accurately as the strategic model. Now, however, it is used for explanation and eventual consensus. I have given you a very small example. A single population of density nt at any time t, and also where n is a continuous function of t, and n satisfies, there is something called the Hutchinson's postulate. Hutchinson's postulate is actually talks about a ratio of the difference in size between two species. If you are talking about two species of people, they are coexisting, there is a ratio of the size differences. Generally, it has to be between 1.1 and 1.11 and 1.14, and they say 1.13 ratio. Between two species, 1.13 should be the ratio of the size difference, or I can call it as a separation for their coexistence. This is I just took a simple ordinary differential equation. Then the solution is obtained. This is based on this. This is for just one. I am talking about a single population. So this is the solution. This is called the logistic equation. The ODE is used. Actually, it was formulated by Sir Ronald Rose, who was actually working on malaria on humans, and he was an epidemiology specialist. But finally, we find that his formula and his methodology is applicable more in ecology, that is the population ecology. Now, I said there are one single population, that is single species. Now, if you have more species, but there is no interaction, the system is modeled by the same set of equations. See, here I have a term 1 minus ni. This is not there in the earlier one. Earlier I had lambda n into 1 minus n by k. A lambda ni into 1 minus ni n by k is there. But when you look at the equation, this is the first one when there is no interaction. But when you have more than many number of species are there, there will be actually a kind of competition among them. They all will be staying in neighboring regions. So they might be having a competition to acquire food. So this equation has an additional term. So this is the first equation when there is no interaction, and you have n species. But when you have a competition for food among them, then you see that there is a n2 will come. I am just looking at species 2, that n is equal to 2 instead of n. So I will get dn by dt of dn1 and dn2. And here what you see is in the first equation I am getting n2, and in the second equation I am getting n1, because there is a competition for food among the two species, and this has exactly one positive equilibrium solution. And if both the numerators are given by n1 star, n2 star, with all these values delta 1, delta 2, etc. All of the k, delta, lambda and delta are positive. If both numerators and denominator are positive, the solution is stable. But if they are negative, the solution is unstable. But how do you check the stability mathematically? Now here comes our eigenvalues. You can find the Jacobian of the system n1 star, n2 star. That matrix, right? 2L, so it will get 2 by 2 matrix, and you can find the eigenvalues of the Jacobian of the system, that is Jacobian matrix of n1 star, n2 star. Now you know what are the eigenvalues, right? For any matrix A, square matrix A, you take determinant of A minus lambda I is equal to 0, and then solve this, do expand the characteristic equation you get. What are the roots of the characteristic equation? They are the eigenvalues. Here you have to look at the eigenvalues of the Jacobian matrix at n1 star, n2 star. This should have, the eigenvalue should have a negative real part. You know the eigenvalues can be real or complex. If they are complex, then you know they have to appear in pairs also. They should have, the complex one should have a real part. They should have a negative real part. We are not worried about the imaginary part. If any of them is positive, it is unstable. I am just giving you a very simple application in population ecology where one works on ODEs, and we have to calculate the this is only for 2. Then I have a Jacobian matrix which is 2 order 2. Suppose I have n species, then I have a big matrix, and then I will have a determine the characteristic polynomial, or the characteristic equation will be determinant of a minus lambda I is equal to 0, where A will be a higher order matrix, and the eigenvalues calculation also becomes more calculated. I know you all know how to find the eigenvalues. So that is actually a measure of the stability from the mathematics sense. Now, when you look at a career in applied mathematics, it is not applied mathematics. Now let us get into applied mathematics. It is not just crunching numbers as many people think. Oh, you use a computer and it generates some numbers. It is not so. It is being able to use mathematics to solve real problems and make an impact in the world. And it is very satisfying and is very rewarding also. But for this, there are some fields that you should have specialized studies: mathematical modeling, high performance computing, that is solving advanced problems and performing research activities through computer modeling, simulation and analysis. I think most of you would know what is high performance computing. But very often, you know, when you have a huge set of equations, for example, when I come to aircraft, maybe I will explain, because we use high performance computing, that a parallel system of nodes, of 1000 nodes, 1200 nodes, etc., where the entire job is run on parallel nodes. Now, these are some professional societies which actually gives you a lot of information on this applied mathematics, Society for Industrial and Applied Mathematics. Prominent employees in India on mathematical modeling using HPC. NAL is a National Aerospace Laboratories under CSIR, which is there in Bangalore. And CMAX, Center for Mathematical Modeling and Atmospheric Computer Predictions and Computing Systems. These people have a huge, I think almost 15 or 18,000 nodes connected in parallel, and the software that are run there also can run in parallel. So they actually do take people with mathematics background who have specialized or who have enough familiarity with computer science, parallelization, and high performance computing. Another is ISRO in the DRDO labs, including where I worked, ADA, IBM, Microsoft Research Labs. These are some of the places. Now, I will just show you how we have used mathematics in Tejas. Tejas is the indigenous fighter aircraft in which I have worked, configuration design to flight testing. So this is the aircraft. Now, in the initial design, I said configuration design here. So in the design, you need a lot of computer design. So what are the mathematical curves that we have used? Bezier curves, B-spline curves, NURBS, that is under one umbrella. Then we have the, as I told you about applied mathematics, partial differential equations under the laws of conservation, approximate solution of PDE by discretization, and how they are used, that is computational fluid dynamics applied to aircraft design. Then we have something called store separation, then a peep into MDO, and also application in military services, particularly in army research. Now, curves and surfaces, when you start doing a design, initially it was people used to use AutoCAD. Now you are going to design an aircraft or any 3D body, you need a 3D modeling software. So that what is used was CATIA, that is a CAD geometry modeler software. It exploits the spline. Initially, it will have some basic curves. Initially, it was Bezier curves. Then they went into B-splines, and then they also have nerves. Aircraft industry uses CATIA with regular updates. The software company that will give updates on the software with additional salient features. Nerves is used to define curves and surfaces in CAD, finite element meshes, and CFD, particularly in the aerospace vehicle design. So these are the emerging areas that we have. There is a lot of interest in biology nowadays. So we have biomathematics, bioinformatics, biostatistics, so many fields where you need a lot of mathematics, statistics, and computer science. So in biomathematics, it's basically mathematical biology, which is a highly interdisciplinary area, which defies the usual categories of mathematical research. Involves real analysis, probability statistics, and computer science. Also, it involves theoretical analysis, mathematical modeling, and abstractions of the living organisms. That is where biology comes into the scene to investigate the principles that govern the structure, development, and behavior of the various biological systems. The value of mathematics in biology comes from applications of statistics and calculus to quantify some of the life science phenomena. And this biomathematics or mathematical biology is at the intersection of significant mathematical problems and fundamental questions in biology. There is a lot of demand for people who are familiar with biomathematics and even biostatistics. Now, another one is bioinformatics. It is an interdisciplinary field again that develops methods and software tools for understanding biological data. In particular, when the data sets are large and complex, informatics comes into picture when the data are large and complex. It is something like the current big data analytics. As an interdisciplinary field of science, bioinformatics combines biology, computer science, information engineering, mathematics, and statistics to analyze and interpret the biological data. This has been used for study in computer simulation, analysis of biological queries using mathematical and statistical techniques. Everywhere, what you need is mathematics and a good background on statistics. Now you have something called climatology. Climatology is the study of atmosphere and weather patterns over a period of time. This science focuses on recording and analyzing the weather patterns all over the world to understand the atmospheric conditions which causes them. Please remember that climate is different from meteorology that I am coming down. Climatology is only studying the atmosphere and weather patterns. Meteorology is the study of weather and weather forecasting, which is very, very important even in our aviation. When meteorology is the study of weather and weather forecasting, this plays a great role in aviation for execution of safe flying in the air. There is what they call a Met Office. The meteorological office will be there in headquarters, air headquarters or army headquarters, and they have very highly advanced equipments. That is the Met Office, and they have the different kinds of equipments to automatically automatic weather solution, distance recording with venting equipment. It will also find out the wind speed and directions. Equipments are there. Ultrasound digital sensor measuring the wind speed with high accuracy. Then digital self-recording RAM gauge. And they also, and what they do is, after collecting all the data, they actually do a modeling and see how they can, here we have to study weather and weather forecasting also. No? So you have to forecast means predict. That means you have to run the entire data in the form of a model and then run the software to you to generate predictions. That means the data is too huge that you cannot do it in a PC or even a workstation. So here again, you need high performance computing systems which can run this atmospheric numerical weather prediction model. And this has to be running 365 days, 24 hours and all the 7 days of the week at the Air Force centers. And they have the systems with 144 processors, and they keep on increasing the number of processors because they need that solution very fast. The more number of processors, you will get the faster solution. So they go on increasing the number of processors, and the weather prediction model is put there, and the software is a parallelized software which runs on this high performance computing system to give you accurate predictions. They also have laser sailometer for detection of clouds and vision obstruction. These are very essential. See, I have been interacting with the Met department also because we were doing actually flight trials. So we should know what will be our calculations are done with some assumptions regarding the weather, temperature, the speed of wind, etc. So, but we confirm it from them, and any correction in the software has to be done, and then the answers before you actually do the flight testing. Then data analyst. This is a very, very lucrative job nowadays. He collects, processes, and performs statistical analysis on large data sets. This is what we call big data analytics. What do you mean by big data analytics? It is huge in volume. Well, the way the data comes to you is the very, very speed. So velocity, veracity is the accuracy, and variety of data. They discover how this can be used to answer questions and solve problems. More nowadays, people are also using to make predictions using some very specific software. Big data analytics. Now, with the development of computers and increasing move towards technology entwinement, we need data analysis has evolved. How do you become a data analyst? Bachelor's degree with emphasis on statistical and analytical skills. We can do mathematics. Nowadays, most of the universities offer an ancillary paper on computer science. Then learn the data analytics skills and get a certification, which you can do online. With that, you can get a first entry level data analyst job. Once you are in the job, you should be able to go do a master's even part-time. But to begin with, you should have a very thorough background in mathematics, little bit in computer science and statistics. And you can do a 6-month certification course on data analytics or a data science, which is offered by many institutes. That will enable you to get a first level data analyst job. Once you are in the job, you have to learn more. Number one, you are learning as you do the job. Number two, you also try to go for a post-graduation where you specialize. And for the skills required are programming skills. R is a software like MATLAB, but R is more statistical. Similarly, SIS is a statistical software for data analysis and inference. Then creative and analytical thinking, visualization of the data, skillful communication, and advanced Excel. Excel software is also very much used for post-processing of the data and calculation. We even write small programs in Excel in the form of formula and then get the values. Now you have how it is used in financial economics. It is indispensable in the modeling of economics, finance, business, and management, as ability to extract information from data is fundamental in science, engineering, and economy. Actually, nothing like mental arithmetic, which is commonly sought after skill within the financial industry. And how are they using mathematics in financial economics? Especially the type of mathematics they use are primarily algebra, calculus, and statistics. Algebra they use to make total cost and total revenue computation. Statistics is used to make forecast and determine the probability of the occurrence of an event, fundamentals, and calculus to find the various derivatives of utility curves, profit maximization, growth models. This is all coming under financial modeling. So you know how much of mathematics is there in financial economics. Now, another profession which is very much in demand is risk analyst, which also comes under that. Prominent employers in India are Futures First and Capita World. Now we have seen biomathematics, bioinformatics. Now let us look at biostatistics. Here again, it is application of mathematics and statistics in health and biological sciences. The word bio says that. What you should be familiar with you should know bioinformatics, which combines computer science, biology, mathematics, and engineering to analyze and interpret the biological data. And currently, there are companies like Cadila, which is actually a pharmaceutical company, and also DE Shah Research. They actually do a lot of research on chemistry, engaged in scientific research and technology developing computational chemistry. But they take people who are specialized in computational chemistry, who are biologists, computer science scientists, applied mathematicians, computer architects, and all will be working together along with the chief scientist to analyze the data and come to some positive come to some useful conclusions. That is what you need in biostatistics. Now, there are some Biomathematical Society of India, International Society for Computational Biology, Society for Mathematical Biology. These are professional societies. You can get information about them from the internet itself. Now, another one is geological mathematics. You know what is geology? So you know about the ONGC and all, where they do find oil and then dig new wells. So they have to locate oil, means they have to find hydrocarbons. So in oil industry, finding or producing hydrocarbons is technically challenging and economically risky also. This generates a large amount of data from different sources like wells. There are also seismic surveys which they do, which data has to be analyzed to take decisions to position new wells for oil rigging. Now there is something called a nighttime light data, which is very much used by the ONGC people, which is a measure of the artificial illumination in the night and is an indicator to measure the growth and economic activities in cities. Now for geology and geological sciences also, there are some professional bodies. The prominent employees are ONGC, Greco, G Technologies, etc. Now we have seen some of this mathematics related to biology. Now let us look at in computer science. Interface of the technology of computers with mathematics. Many common subfields are there between mathematics and computer science. What all you should know is discrete mathematics and cryptology. I'll just tell you in a minute what is cryptography. And you also should have parallel computing in a high performance computing scenario. Professions in demand are cryptology and network security analysis. This all the cyber security, everything comes under cryptology. And there are so professional societies also for this. And there are companies like Google, IBM, Microsoft, Yahoo. They all actually need people who are specialized in cryptology and network security analysis, because whatever data we use in our internet, that has to be secured. Should not have access to other people. No. So how it is done? No, that is done through cryptology. Cryptology is the practice and study of techniques to secure communication in the presence of adversarial behavior. So actually it is subject, basically it is cryptography, and the cryptology is the practice. In generally, cryptology is about constructing and analyzing protocols to prevent third parties from reading private messages. That means the security of your personal information. Various aspects in information security, such as data confidentiality, data integrity, authentication, and non-repudiation are central to modern cryptography. And this is they call it an encryption and a decryption. You convert it into, you have to use a private message and through a protocol, and the person who is receiving will be able to access it. No other people can access it. And cryptography, again, is at the intersection of the disciplines of mathematics, computer science, electrical engineering, communication science, and physics. Applications include electronic commerce, chip-based payment cards, all our credit cards which are chip-based, the security, the digital currencies, computer passwords, military communication, all of them are fully based on cryptology or cryptography. And now we have OR, operational research, that I'm sure most of you would have learned a bit of operational research in statistics. These are the operations of to make decisions, to create policies. And this is very effectively used by the airlines to do smart scheduling of the flights. You also would have learned about the transportation problem, salesman problem, etc. in OR, optimization. Now, very similar, at a much larger scale, it is used by the airlines for smart scheduling of the flights, which will enable them to bring down the cost and also do a smart pricing to maximize their profit. Now you have to identify the business problems and collecting the information and data, then generating simulation towards solution in practical terms. And for in OR, important fields of specialization again are optimization and data analytics. And we have an Operation Research Society of India, International Federation of OR, and people like Adobe and Morgan Stanley, they do take people who are specialized in operational research, optimization, and data analytics. Now there is a path which is less traveled by mathematicians. It's a startup company, Renaissance Technologies, which is known as a new startup company is there, which is an investment management firm which specializes in systematic trading only using quantitative models which are derived from mathematical and statistical analysis. See, so much of mathematics and statistics are used by them to analyze the data. Based on that, they advise people to make investment management firm, and the firm is regarded as the most successful hedge fund in the world. This Renaissance Technologies. Now, role model in India also, there is one lab, one Eritty lab. They concentrate on using mathematics and physics for engineering innovation. They provide end-to-end technology research and development service with deep expertise in mathematics and engineering and workflow, which spans mathematical modeling to address real-life problems. And they use multidisciplinary engineers and scientists. They have engineers and scientists who are specialized in different disciplines, including mathematics and statistics, plus the other engineers, depending on the type of projects that they have. Now, these are a few places where mathematics people can do internship, MTTS, Mathematics Training and Talent Search Program. And what they do is skill building. And it has got an email, mttstrust@gmail.com. If you send a mail to them, they'll give you a lot of information. Then again, the earlier one I saw, B. Shah, no? B. Shah Research Lab, they also take summer internships. Microsoft Research takes. IIT Bombay, I know IIT Govt, they all take research internships. Then PAFR take visiting student research program. ISC also has summer fellowships. And IMSC, Institute of Mathematical Sciences, also has summer research programs. Similarly, HRI, Harichandra Research Institute, they have summer program. Chennai Mathematical Institute also has internships and visiting students. Now there is something called the National Network for Mathematical and Computational Biology. So this is also something those who have a flair for biology besides mathematics can look into this also. They do take internships for bachelor and master students. Now there is another program which is probably maybe 2012 or 14 started, National Program in Differential Equations, NPDE. It is TCA, Theory, Computation and Applications. This is from IIT Bombay Department of Mathematics. They do summer internship program sponsored by DST, which gives opportunity to undergraduate and postgraduate students to participate in short-term projects. And this is the email of that, www.npde-tca.math.iitb.ac.in, which is actually the mathematics department of IIT Bombay. Now, this I see, you know what are the challenges just by doing a B.Sc or MSc Maths. Nowadays, actually in Ramaya University, I know MSc Mathematics, they have a compulsory paper on AI and ML, Artificial Intelligence and Machine Learning. And with that, they all try to do some online 6-month certification course on data science, so that many of them after MSc, they try to get into a job and then build their career by going in for higher studies. See, directly our way may not be very broad. We have to broaden our specializations and our knowledge, our expertise. So how to prepare a career in industry. As I told you, not most of the people who complete doctoral students, we are not able to get jobs for them in academics, universities and colleges where you do teaching and research. So when you want to prepare for a career in industry, you should go with an open mind and equip yourself with whatever they need. Mathematical maturity helps in looking for beyond a problem, understanding the big picture. Then you have to learn enough statistics to be able to model the data. Mathematicians often work with the data scientists. So the statistics, people who have learned statistics will do some modeling of the data, and the mathematicians will give them directions and help them to do the analysis and come to inferences. Acquire basic knowledge in computer science, especially in programming, programming proficiency. You can learn C or you can learn C++. MATLAB is a technical software, say Maze, or it is more of a statistical software. And let me tell you, MATLAB is not a free, but R is a freely downloadable software. And with the inbuilt manual, it is very easy to learn how to use it. It has got a lot of mathematics and statistical functions and capabilities. You also have to look for research in or industrial internships during the vacations. Develop good oral and written communication skills and be ready to work in a team and be a team player. It is nowadays, it is not that no one person cannot take up the work. You are always put in a group where you have a mathematician, a statistician, a data scientist. All of them will put in their knowledge. It is a brainstorming session on a day-to-day basis. They put in their knowledge, and then you have to work as a team. So instead of being a loner and working alone, we have to come out of our shell and learn to be a team player. That will take you to great heights. Now, what we can do is join a network, join a professional society. What many societies names I have given. This enables you to network with people of similar interests and expertise. And as much as possible, attend conferences, symposia, summer school, winter school. Here also conferences and symposia where you meet people who work on similar fields of interest. Then learn new mathematics regularly and quickly. When I say new, what is new and applicable to either to your interest or to your job requirements. Learn the fields of your teammates or clients so that you can help them when you are doing some work with the pharmaceutical chemistry people. For example, pharmaceutical industry, they do take biostatisticians. So if you know a little bit of pharmacy or chemistry, it will help you to understand what they are doing. So it will probably bring out the best in you to apply your mathematical and statistical techniques. So what are the skills you need? Active learning, communication, decision making, and system analysis. Now for all these, there are a lot of open course where one is the MIT one, another one is the Coursera, NPTEL online courses. These are there. And before winding up, I just tell you about the mathematical institutes in India. Most of you would know, but I have just collated them. Chennai Mathematical Institute in Chennai, Harishchandra Research Institute in Allahabad, Ramanujam Institute for Advanced Study in Mathematics, which is the Department of Mathematics of the Madras University, the Institute of Mathematical Sciences in Chennai, then Department of Mathematics at various IITs, ISERs, NICER, ISI Statistical Institute, EIFR, IISc, and Department of Mathematics at various universities. Then there is also the National Mathematics Initiative, National Center for Mathematics. Now there is the Mathematical Science Foundation, which is registered as a non-profit society and is an institute of education research located in Delhi in India. Its goal is to promote mathematics and application at all levels, starting from school to college to research. Now, so that much is the end of it. If I'm able to open the other file individually, I will just show you because something very important I wanted to show you. But anyway, I will close this file. I am extremely thankful to Dr. Vijay Kumar Ramba, Dr. Vinod Kumar, and the entire Maths Aspirant Group for inviting me to deliver the national webinar talk and having given me a very patient listening. That is all. Now, let me see whether I can open the other file. Okay. It is not opening. Now, I will put it as setup slideshow. Browse by an individual manually. Okay. Then we will see whether it can be opened. Is it showing stop presenting? You can see this, right? Slide show.
Yes, ma'am.
Yeah. Now you see whether it has gone to the second one.
That's right.
Yes.
Yeah. So first few we have done. We were doing here Bezier curves. Now I think I am not sure whether most of you, we don't actually do these Bezier curves in our mathematics. But when it comes to computer-aided design, these are very, very important. This is what are from the basis functions, basic curves in computer-aided design, which is actually used for a numerical master geometry in any project. The Bezier curve, it will have 4 control points, and by joining the points, what you get is a control polygon. Please note that Bezier curve will not interpolate the given points. It will only approximate the points, and the curve will always be within the convex hull of the polygon. That polygon means when you connect the points. When you have 4 points, you will get a Bezier curve of order 4, that is degree 3, order minus 1. And also, because it is a single curve where I am using Bernstein polynomial, the curve has no local control, it is global control. When you change one point, the entire curve will be changed. Equation of the curve. So what you are seeing is the representation. The curve is calculated inside. I have actually given how it is calculated inside. You are given a point, I represent it. In all these, they generally have a parametric representation. So given the points, first what you do is find the parameter. What is the parameter we take? When the points are very closely kept, or a dense distribution of points, the arc length between two consecutive points, arc length can be approximated by the chord length when the points are near, right? So that is what we do. We take the arc length between 2 points as the chord length and go on cumulatively doing it. So at the end of the end points, what you get will be the total arc length of the curve, which is approximated by the cumulative chord length. Now you do a normalization. First point I put the parameter as 0, and last point will be max. So now you define the parameter S as S of I is T of I by T max. So T1 is 0, so S will be 0. T of N will be T max, so S of N will be 1. That means I am taking the arc length, cumulative approximated chord length normalized. That is what I mean. Normalized means I am dividing by the maximum length so that the variation is from 0 to 1 arc length. So these are all what is generally done in computer-aided design softwares, 3D modeling software. And the curve is represented by summation Bi J3 of I S, where summation will be depending on the number of points. Suppose I have 4 points, I put it them 0 to 3. Bi are the points whose coordinates are x and y given, and j are the Bernstein polynomials. So they form the basis function. The Bernstein polynomial form the basis function. The number of points are more, the degree will be more, and then the complex shape also will be more, and it is difficult to use because each point will influence the whole curve. Now you have what is called as splines. Now splines curves, what we do is you have an interval AB. That interval you divide into maybe n intervals. So n2 points in between n points A and B, in between A and B, you put n minus 1 points. In each interval, you define a polynomial, separate polynomial of degree n, degree k, for example. So what happens is you have kn intervals, each having a polynomial of degree k. Now, how do you evaluate the polynomial uniquely? You have to, any 2 neighboring polynomials should have orders of continuity from 0 to k minus 1. The point, the first derivative, second derivative up to k minus 1 derivative should match at the common point. And kth derivative will be, for a kth degree polynomial, kth derivative will be a constant. So it will be a step function. That will be different. So you will get the number of conditions, and we also put some boundary conditions, and we can have either an interpolating or an approximating. This is an approximating, and this is where the curve passes through that, and or you can have a least square fit. That means what is meant by least square fit, the sum of the squares of the errors between the actual value and what you get should be minimized. So in this case, as I said, these are the points. The points in between are called knots. Each is a polynomial. When all knots are distinct, we can say that the derivatives are continuous up to k minus 1th. In this case, this representation is sigma ai bi, because any spline function of degree k on a set of knots is represented like this. These, instead of Bernstein polynomial, what I have are the B-spline. B means B is for basis spline function, and these functions are like this. They have what you call in mathematics finite support. Outside a finite interval, they vanish. That means any curve, any point you change, for example, if a curve, B-spline curve of degree 3 maximum, you will say 0, 1, 2, 3 up to 4 only. Only any one point changing will only change the curve in neighboring regions only. That means this gives you local curve. This is because the B-splines have finite support. Then from there, another important thing is these B-splines are such that they form each of them is non-negative, and they form a partition of unity, which means when the summation of the functions as the parameter is between 0 and 1 is equal to 1. Now from B-spline, you go to the more general one, which is a NUBRS, non-uniform rational. Rational means it is a ratio of two polynomials. So the function is basically what we have here is Bi. Here I am writing instead of Bi one Ri. That each Ri basis function will be a ratio of two functions, where I am introducing a new unknown quantity called Wi. And these are again the basis functions. Note that when you put all Wi's is equal to 1, the numerator is the n of ni, which is the same as b of n. And here Wi is 1 will give sigma nj n of u, which is 1 because they form the partition of unity, which becomes the same as the B-spline. That means when you put all the weights is equal to 1, nerves become the standard B-splines only. From the curve, you can get a surface in terms of the tensor product, where you have two parameters, u and v. This is the nerve surface of degree n. I have a point having coordinates suffix p of I comma j. I will be along one direction, u and v are there, no, two parameters. So those indices are I and j. Now, when you look at mathematics in fluid dynamics, you have the governing equations, basically partial differential equations. Those are partial differential equations are coupled and very complicated, and we cannot get a closed form solution. So we need to have only numerical methods and get the approximate solution. So what you do is we discretize, and discretization is of two types, and then you get a system of algebraic equations which you solve numerically, and that will give you approximate solutions. Now how does mathematics appear here? There are three branches within fluid dynamics. One is experimental, one is analytical, one is computational. Experimental is not within our scope. We actually take the aircraft or component model and do testing and measure the forces and moments. So that is not coming under mathematics. We are interested in analytical and computational. As I told you, the PDs, the governing equations and the boundary conditions are so complicated. It is not possible for us to get a closed form solution that is an analytical solution. So we always go for computational. That is why we have the CFD. Now fluid dynamics is not only mathematics, it also involves a lot of computer science. When you talk of CFD, it needs not only mathematics, it also needs computer science, because it integrates not only fluid mechanics with mathematics, also computer science. What it does is influence of the fluid flow on the processes, which also includes heat transfer, chemical reactions in combustion flows. This is when you are talking about the internal flow. But there are also flow on the surface of the aircraft, which we call as external flows. Now all the flow characteristics are determined by partial differential equations, which are the governing equations. And these equations, as we saw earlier, they are based on the conservation laws of physics, conservation of mass, momentum and energy, and you have the mass conservation, Newton's second law, and the first law of thermodynamics, which is physics. So this actually shows how the equation comes. The first mass flow is this equation, d rho by dt plus d by dx of rho u. U by w will be, you have to solve this equation, partial derivative, because you have rho u, rho v, and rho w, and UVW. These are the velocity components along the 3 axes of coordinates at any time t. That is this t. Now, what do you mean by discretization? When you talk of a body aircraft or maybe a ship or maybe any of the satellites, launch vehicles, we are actually interested to study the behavior on the entire surface. That means our domain is continuous, but we cannot calculate. No? So what you do is you do discretization. That means you put grid points and you find the solution only at the grid points. That means the coupled equation and boundary conditions are transformed into coupled algebraic equations in discrete variables. So here what I have mentioned is I have the closed interval 0, 1, which is a continuous interval. On that, I decide how many points I want to put. I will put n points, and the value of p at each of the n points is defined as pi of pi, which is pi, p1, p2, p3, pn. So from the continuous domain, I have come to a discrete domain having a finite number of points. And these equations and the condition in terms of these continuous variables are approximated in the discrete domain. Now the CFD solution is computed for the variable. Then we get the solution only at the discretization. This is what we call grid or a mesh generation. So what happens is we'll be getting the solution only at the grid points. And if you want to find the value at any other point, we do interpolation. Now you have to, once you set up the discrete system and solving, system is set, solving is done by using high performance computing system, using parallelized codes, and the system also is connected in parallel with high number of nodes. Now here when I say interpolation, it is not just linear interpolation. You are in a 3D, right? So in a 3D, suppose I have the 3D box, when you take it has got 8 vertices. I may have a point, something inside that or somewhere outside. I don't just take 2 points. I find the nearest 8 points and take a weighted average of the values there at that point as the interpolation value, where the weights will be the distances. So if it is close to a point or it is far from a point, we take that into consideration. That will be more accurate than taking just a linear or a bilinear interpolation. Now, how do you do the computational techniques? Conversion of the PDE and its auxiliary, that is initial and boundary condition. This you all have done in your mathematics, right? ODEs and PDEs, where you have initial conditions, you have boundary conditions. So by some method, by discretization, you are able to get into algebraic equation. Then you implement the numerical methods to solve. These equations are computationally intensive, and so you need high performance computing to get the solution in reasonable time frame. The present HPC tools are due to the innovative hardware, software, and algorithmic advances. Because of this, it is possible for us to use CFD in a very accurate manner to predict the major features and the velocity and the pressure. Thereby, we are able to bring down the wind tunnel cost. Wind tunnel is what I said earlier as experimental, and also cutting down the cycle time. So this is just the aircraft flying. Now this is the light combat aircraft. This is a fighter aircraft. So here what you see, this is the nose landing gear. These two are the main landing gear on which the aircraft sits when it is on board. And here these three are places which are called, here you have a missile, here and here you may have a bomb or a fuel tank. These are external attachments. So these are called external stores. Now during the flight, the aircraft flies maybe at a level flight or a climbing or a diving at different speeds, different altitudes, different angles of attack, attitudes. We have to calculate when you release a store, that may be a bomb or a fuel tank. What we do with the fuel tank is during the initial starting of the aircraft taking off, the fuel from the fuel tank will be transferred to the main fuel tank, so that this will have only very less 1% or 2% of unusable fuel. The purpose is, in the case of a fighter, it's a combat scenario. If the person, you have to bomb the enemy and fly away, you want to fly at a higher speed, you can throw away this. Hence, it is called a drop tag. You can drop it. If there is fuel, it is highly inflammable. So it is most unsafe. So what we do is you use all the fuel in the initial stages. Fuel is, there are pipes, tubes by which that fuel will be transferred from the fuel tanks to the, from the drop tanks or the fuel tanks to the main fuel tank of the aircraft. And now when you release this, you should have a safe separation. Two things are there. One is safe separation, one is hitting the target. Safe separation is actually calculating the trajectory in the first 2 seconds. And after that, whether hitting the target or not is the job of the avionics people, that is the electronics of the aircraft. So we had to predict the trajectory of all these different attitudes, altitudes, etc. That is called a store separation studies. Now, I will just show you, this is the aircraft axis, this is the along the length, this is along the wing, y-axis. Some people put the z-axis down, some people put the z-axis up. For us, x is from nose to rear, wing is this way, and z is positive. That depends on the convention. Now, aircraft can rotate in 3 dimensions, because you can rotate with respect to out of any of the 3 axes. And these lines you see are meeting at the center of gravity of the aircraft. Center of gravity is where the weight acts. Now, which will be, yes.
Hello, ma'am. There is a humble request.
Yes.
Since we are all also waiting for the interactive session with you.
Yeah, no, another 2 or 3 slides only, ma. Another 2 or 3 slides. That's all.
Oh yeah, that's perfect, ma'am. We were just
a few more, because this is a very important application of mathematics in store separation. I know how much I have struggled. I have struggled a lot, because what you predict the trajectory does not happen in the trials, no. So how we have to make corrections. So it is completely mathematics. That is why I thought I will tell you.
A few more minutes, ma'am. That's definitely
fine.
No
See,
problem.
even if it is beyond 4:30, I can have interactive session. So you have the aircraft can be movement of the nose from side to side. The aircraft can go up and down like this. It can go like this, or it can do roll. So 3 motions are there. That is the store separation. Equation of motion to numerically model the free flight, restricted pivot releases. We are going to press them with a ejector force, or ray release of missiles from a rail launcher, or arbitrary maneuvering aircraft. So we have the what you call a 6 degrees of freedom, which refers to the number of axes that the rigid body is able to freely move in the 3D space. So what are they actually? You can move in XYZ directions, and also you can rotate with respect to the 3 axes. So totally you have 6 degrees of freedom. A very good example of an object having 6 DOF. We call it 6 DOF, which is very, very important in the control and guidance of the aircraft. Airplane, 3 translational and 3 rotational movements with respect to the 3 axes. They are the, first you have the evolution with respect to time, position with respect to the frame, that is XYZ. Velocity will be x dot, y dot, z dot, which we call UVW. Then the 3 angles by which the body is fixed to the with respect to inertial frame, that is, we generally write it as phi theta psi, and then the angular velocity phi dot, theta dot, and psi dot. These are all nonlinear functions of mass, moment of inertia, forces and moments, etc. Now I have just put, we generally make the matrix, the rotation matrix, starting with an Z rotation, then a Y rotation, and an X rotation. If when you do an Z rotation, this is what you get, because the matrix I didn't write, just to tell you. But whereas if you start with a X or Y in the beginning, you will get a different set of points, for the simple reason matrix multiplication is not commutative, right? So whichever, when you change the order of the rotation, the matrices also changes. Now you have the, as I told you, you have the 12 equations of motion. These equations are a set of ordinary differential equations in time. And again, they are coupled ODEs in time. We do not, and there will be some initial conditions also. We do not get a closed form solution to this. Hence, we need to solve them numerically. So what we do is, generally what you do, this is the form of the equation. First derivative, x dx by dt equal to f of xt. So you will be given the value as some t is equal to t naught. Now, when you take a t plus delta t, you can find x at t plus delta t using the Taylor expansion. Again, we are coming to basic mathematics and calculus, but this needs higher order derivatives. But from here, we have only first derivative. So we have to apply some numerical schemes to relate this x dash to higher order derivatives. Now, alternatively, most of the time what we use is Rangakuta fourth order, higher order method of Rangakuta, which is again time marching from one time step to the next time step by a series of intermediate evaluations. So finally, the entire ODEs, the 12 ODEs that we have, they are very complicated ODEs. We generally try to simplify and then use Rangakuta fourth order. Though I have written higher order, it is generally fourth order, which is actually used to get the approximate solution. Now there is something called optimization, which is also done in the aircraft. I think you all would have learned about optimization. You have the design variables, you have the inequality constraints, you have the equality constraints, and you have the objective function. So see, what you do in school and college are basically only classical methods where you use continuous and differentiable functions based on differential calculus techniques, but these are not applicable in complex applications. Again, we go for numerical methods. What you do is get a sequence of improved approximations to reach the optimum value. Start with a point and then you find a direction in which points to the general direction of optimum. When I say optimum, I mean maximum or minimum. Then how much you have to go is given by the step length. So get the new point xi plus 1 equal to x of I plus lambda star into s. See whether xi plus is an optimum point. Otherwise, go back to 2 and continue till you get the optimum point. Or sometimes what happens is you may not be able to get the optimum point. Will be where your gradient is a generalization of your first derivative, right? Gradient means it is you put for a function of one variable df by dx is equal to 0. Instead of that, I will have partial derivative df by dx1 equal to 0, df by dx2 equal to 0, etc. for a function of two variables. So df by dx1, df by dx2 is the gradient vector. And from there, you go to second derivative. Here, second derivative becomes what you call the Hessian matrix. I'm not going to any of those things. So in design methods, numerical optimization procedure, you need the objective function, the design variables, and the optimizer. So what we generally do is we don't do offline. We integrate all the procedures by proper integration of the optimizer will be a software. So CFD solver will be there and geometry representation. All the three are integrated into a single software and automated so that once you start the problem, it is finally going to give you the intermediate solutions and the final optimal design. Now, this is only when you have one thing. Now, what happens, when you, in case of an aircraft, what happens is when you do an optimization, for example, I want to decrease the drag. I want to have a wing with a long span. The efficiency, aerodynamic efficiency will increase, but the weight will aerodynamic efficiency will increase, weight also will increase. Weight will be from the structure side. So what you have to do is multidisciplinary aerodynamics and structures. We have to have a via media where you get the best solution which satisfies both. Best solution of aerodynamics will be very heavy. That I don't want. I also don't want something with a very small aspect ratio, a small span, because in that case your drag will be high. The drag is high, then it's going to consume a lot of fuel. So we have a new method where it is multidisciplinary design optimization. This is applied to aircraft design, is one of the most challenging and emerging fields, and we have very effectively used that. Now, in defense, what happens is, when I say defense, it is mainly army. Army, all I talk to is more of Air Force than in general. So I just tell you what army is interested. Mathematical research, they want interactive and collaborative. Then these are the fields that they are interested. They have 6 components of defense mathematics research, mainly army, applied analysis, computational mathematics, probability and statistics, systems and control, discrete mathematics, and intelligent systems. Now, I have not given the explanation for all of them. Intelligent systems is what they are very much interested, and they exhibit emergent behavior, large intelligent controls systems are very intensive computationally, and research on mathematical modeling of these intelligent systems is a very emerging and challenging area. Intelligent controls has applications in automation, robotics, and distributed C3. C3 means command control and communication, which is a very common word in defense. And what the research is, control systems to general functions of decision making, selection, mode switching, scenario identification. Most of these not during a war scenario. Even when you are not on a war scenario, they want to identify all the possible intelligent control that they can have, so that in case of a war, they know how to go about it with the minimum turnaround time.
The presentation itself shows how much dedication and effort you put. We all are so thankful to you. So I'm reducing my words and we are directly entering to the interactive session. As we all know, that's the beneficial part of any national webinar. And so I welcome now all the participants to ask their queries. There were a number of queries in the chat.
Thank you. Nice presentation and very informative session. And mathematics can be used in aerospace mathematics. It is very interesting in aerospace.
Yes. Thank you.
So, very nice presentation, ma'am. Okay, ma'am.
Ma'am, the presentation that you showed, can we have the slides? Can you make the slides public?
I think it has been recorded. That's why I removed a lot of classified informations and pictures of the defense aircraft, etc. I just gave you, this is unclassified information. I think Dr. Vinod Kumar has recorded it, no, sir?
Yes.
Yeah. In case you want, I can send you the full slides also. No issues.
Good afternoon, ma'am.
Yes.
I'm Lakshmi Prasanna.
Yes.
Yes, it's very useful interaction with you. Wonderful guidance, ma'am.
Thank you.
Thank you for teaching and guiding such a wonderful applications of maths in our daily life and in every sector. Thank you, ma'am. It's fabulous, ma'am.
Thank you. Thank you.
My name is Alina Anna Matthews. I'm from Kerala. Thank you, ma'am, for giving us such a wonderful presentation and for spending time with us. Your presentation was very detailed. Can you tell me how you came into this defense field?
Yes. After my PhD at IMSc, that is Institute of Mathematical Sciences at Chennai, I went on a postdoctoral fellowship too. Actually, to tell you frankly, I have done my PhD on functional analysis. Okay. It is completely on Hilbert spaces, Sobolev spaces, and spline function, lambda cardinal spline, generalized splines, then approximation, interpolation, norm preservation, very, very abstract mathematics. But then I got this postdoctoral fellowship in the University of Pittsburgh. When I went there, the professor in the Department of Mathematics and Statistics, he told me, your work has applications in automobile design and aircraft design. And what he had, the project on which he had put me was a General Motors project. I had sent him a small abstract of my thesis. Based on that, he offered me the postdoc fellowship. And I was there actually helping the General Motors project. It was more of, smoothing of the surfaces visually, not geometrically also, visually also it has to look very nice and smooth. And at that time, we don't know much of aerodynamics, no? There should be nice, smooth corners and not blunt corners because it will increase the drag. All those things were not known. It was more from the mathematical aspect. But I also learned a lot of coding, running the programs, everything there only. So once I came back, I had applied for this job, and when I went for the interview, my director asked me, in what way you think? See, it was a very new and very attractive project for everybody. So Dr. Kota Harinarayana, who is a Padma Shri, for this flight of LCA, he asked in what way you think you can contribute to the, as a mathematician, and you are just back from US. Then I said, sir, mathematics is the language of science and technology. To put in simple words, anything you want to do for the aircraft design or any branch, you need mathematics. Then he asked me if I put you in CAD. Initially, I was in CAD till we had enough resources for fluid dynamics. Initially, I was in CAD. I was writing software for Bezier curves and B-splines and everything, because most of them were not available at that time. The software, many of the softwares are not available. Then I was put into aerodynamics group. And then it was a long way up the ladder. That's all. You have to study, but
Thank you.
basically aerodynamics you will learn when you learn how to solve the partial differential equations, right? The various ways. I don't know if any of you have learned fluid dynamics or applied maths or those. If there are the most complicated equation is the Navier-Stokes equation. From that you remove the viscous terms, you get the Euler equation. Then you have the full potential equation. Then you have the simplified one, what you call as Laplace equation. So at different speeds of the aircraft, each of these equations can be used. For example, what you have learned, del squared of I is equal to 0, can be 2D, can be 3D. That Laplace equation can be used only in an incompressible region, that is at the very, very low speed of the aircraft. So all those we have to study, right? And also a lot of aerodynamics and how to do the run the codes, everything. But it was a wonderful learning experience. Then regarding the trajectory, what I told you now, no, we predict using mathematical all these equations, Randall-Cotta fourth order method, very complicated equations. We predict the trajectory. I showed you, no, the aircraft is there, the store is underneath. So when you push it with a force, ejector force. So there is and the aircraft is flying. No, you put so much of force. For every action, there is an equal and opposite reaction. No, when you put, there is a chance it will go back and hit the bottom of the aircraft wing. So we have to make sure that it is a safe release. It has to come down safely. And then after 2 seconds, the avionics people will see whether it is hitting the target. And we had some very highly advanced systems to capture. There's something called the ASVS cameras which are kept in the thing. So when it is released, it will capture all the photographs at different levels. And there is a software which will convert the photograph into numbers. And we would have calculated the trajectory at after every 0.5 seconds, 0.5, 1.5 and 2 seconds. So they don't give us what is calculated. They take the data from us and they plot. The flight testing people, they plot our numbers, that is X, Y, Z, the translation and the rotational data. They plot and see whether our numbers are matching with the actually flight capture data. If it is, sometimes when you look at it only, I know as it is released, I know, oh, it is going away. My calculation is wrong. We can look at it because they play the video immediately. So you discuss with them and then make corrections in your software. And then again run the code and get it close to that value. Then only they'll go to the next test point. So I think last two or 3 years, most of the time I was traveling to Air Force bases. This testing is done in Pokhran. We all would have heard of Pokhran, right? In Rajasthan, where they had the nuclear blast and all. There is a huge field for the defense. So all these trials and learning and all are done there. So we will go to Air Force bases which are near Pokhran. Like we used to go to Jaisalmer, Jamnagar, Jodhpur. These are the main 3 things. And when we wanted, these are deserts. When we wanted sea level, we used to go to Jamnagar. At least 15 days of the month, some of us, I was always there. And then they release it. And then they will come back to you with the data in the evening. Oh, this is the result, what we have got. Your numbers are matching. So we'll have the next point tomorrow. So we calculate again and give them. Trajectory means you have to see the path that the body takes as you release it, no? So that is very, very critical. They are not ready to accept your predictions. They want to actually prove that what you have done is correct. So what they do is from the inventory of the Air Force, they take some of these things, they diffuse it so that it doesn't burst and release it. Especially fuel tank means it has 2 compartments. There will be fuel or equivalent to that of weight, and we will say front fuel and rear fuel, partly empty, partly full. And each of those cases at different attitudes and altitudes, they release it. When they release, the particular item is gone. But Air Force is ready to lose the item because once it is thrown from an altitude, no, maybe we say 4 or 5 kilometers, 5, 6 kilometers, we slowly increase the height and the speed of the aircraft. Every time you do 1. So in 15 days, they will be probably doing 10 of them. So they want to validate that your trajectory predictions are very, very accurate, maybe within 2 to 3% of error. That error band is well defined. So that is how it has to be. But then you learn a lot of, this is where you interact with the pilots, right? The pilots who fly the aircraft, they teach you a lot of things. So you should be ready to learn, go to all these places. I have gone to a place called Uttarle in June where the temperature was 45 to 47 degrees. You just could not sit in the hangar because the hot air will be blowing, no? But you cannot complain. It is part of your work. No? So this is a major achievement for us. And now this aircraft has a separate squadron in Coimbatore. Now it is under the manufacturing level. Manufacturing is not done by our office. It is done by HAL. And lot of interaction with the structures people also. Because when you take the total load on the aircraft, it is the aerodynamic load and the structural load. You give the aerodynamic load, then they put the structural load and they add, they see what is the efficiency and calculate, we predict the behavior of the aircraft. No? So we all call it the turbulent flow, turbulent flights we had. But eventually you see what you have learned, right? That is what matters eventually in your career. Alina,
am I audible?
Tell me, who is it? Dina. Alina.
Ma'am, I'm Dina K.
Tell me.
I'm Dina K from Government Victoria College, Palakkad. Ma'am, thank you for your wonderful webinar. Ma'am, I have a doubt.
Yes.
Can you please explain the scope of maths students in data analytics or forensic science?
Data analytics maths in data analytics and forensic science. See, forensic science does not take too much of data analytics. Okay.
Okay, ma'am.
Yeah. Forensic science, actually, people go to the sites and do all the measurements and then bring the data. The mathematicians will look at the data, analyze the data, and finally say what is the exact location of the crime using all mathematical formula, trigonometric ratios, all those things only. Okay. So that is where trigonometry is used, and whatever information they have, that the statistician will, with all this information that is collected from the crime scene, they calculate the probability that the event has occurred. That is the statistician's job, but he needs enough information from the people who collect the data and also the mathematician.
Okay, ma'am. Thank you.
Data analytics, one field that nowadays people are using. I am not sure whether you know, because one of my close friends, what they have done, this Chennai Super Kings and cricket matches, no? These people have historical data of all the batsmen and the bowlers. And what they are doing, it's huge data. As I told, the data analytics, we call it as a 4V: volume, variety, velocity, and veracity. Huge data they have. Initially, they did not even have a web separately site. They were using Amazon Web Services and all to store the data. And then they take each candidate, each batsman or each bowler data, they do the analysis, historical data for many years data they collected, they got the project. So based on that, they predict how they are going to perform in the upcoming match. So with that score, whether it's a bowler or a batsman, with that prediction only, the team was selected. And first time, I think they said whatever their prediction was very correct. Whoever they suggested, all of them played well and the team won also. And if there is one of them who doesn't come very close to your prediction, then there are ways by which you can take some more earlier data and then analyze. Data analytics, for that they use some software. Generally they use some statistical software like capital R. And sometimes they also have user-defined functions and softwares. What they do, these are some of the sports, or everywhere they are using data analytics now. No? Very huge data, they use analytics, and you need high performance computing. Otherwise, you can do it in a PC or a workstation. I don't know how many of you are exposed to coding and computing and all those things. Not much, I think, no? How about you? Arjuna, you are doing pure maths or applied maths?
It's pure maths, ma'am.
Pure maths. See, pure maths, nothing like pure maths. But after I came here, I was actually get to do the best of both. That was it.
Ma'am, I have one more doubt.
Yes.
Is it compulsory for is it IELTS compulsory for getting admission in every abroad universities?
What is compulsory?
IELTS. IELTS.
No. If it is maybe London, UK and all, they need IELTS. But generally, that is more actually on the nursing category is what I think. Our side, they need what is called TOEFL, TOEFL, Test of English as a Foreign Language. TOEFL
If we
and
want to,
GRE.
ma'am, if we want to study for higher studies in abroad, what are the fellowships, ma'am, and how we
No,
can
it depends
apply?
on what type of university you want to go, whether you want a scholarship, you want a tuition waiver, everything, is it not? What do you want to apply, US or Germany or UK?
Ma'am, I asked in a common way that
No, what is
for
your,
every other
what are you
university,
doing now? Tell me.
B.Sc Maths students, ma'am.
Okay, after
Finally.
this, you want to do MSc, right? Without an MSc, see, you should have 4 years of education. That is why the new national education policy has made B.Sc to be 4 years. After 4 years, you can directly go to US. US, otherwise, engineering people, after 4 years of engineering, they go abroad for MS, no? Or B.Sc people cannot go. You need to have 4 years, or at least first year of MSc you do. Instead of that, you do 2 years of MSc, and then go to places where they have people to guide you in your topics of interest. That is very, very important, right? What is it that you want to do, Tina?
Ma'am, I am preparing for JAM, ma'am.
Okay, oh, wonderful. JAM is for IITs, right?
Yes.
Very good, very good. You must be attending all these coachings and directions from this team, right?
Yes, sir, Vinod Kumar, sir.
Oh, Vinod Kumar sir and his team Maths Aspirants. Yes. I had told sir, you put me also into that. I can also join.
Yes, sir.
Hello,
Good,
ma'am.
sir.
May I ask one more question?
Sure.
Yes, ma'am. Ma'am, I cracked IIT JAM exam and I got enrolled in one of Central University, which is in Punjab. Now I'm pursuing my postgraduate MSc in mathematics, and I want to make best use of this 2-year period. What should I do? Like, please guide me so that I can follow that trajectory and get the most out of that.
You are doing pure maths or applied maths?
It's a mixture, ma'am.
Okay. But you may have some core paper, you may have some elective papers also, right? In all the semesters. And do we have a project in the last semester or something? No.
Yes, ma'am.
Project. So, no. What is your passion? Which is your subject, passionate subject?
Ma'am, maths. I want to teach math. Like, I want to crack CSIR net exam and I want to become a assistant professor.
Okay. Oh, you want to be in teaching and research. But first you have to do PhD, right? You can do in India, you can go to a good university abroad, do PhD and say come back and give the exam. Or yes, that is best. Or you can do PhD in India itself, no? If you are not keen, or you can go abroad, a good place.
Ma'am, without doing PhD, only qualifying CSIR net exam, I can also become an assistant professor.
You know, CSIR net, generally, I think they want PhD. No, sir, I'm not very sure. Sir will know, right? Sir, they want PhD, sir?
Yeah, they have planned to make PhD compulsory, but not still.
Not yet done, okay.
Yeah.
But even if you do B.Sc and give the exam and clear it and get a job, if you are in teaching, within so many years, you have to take your PhD. That is the rule. Otherwise, you won't get promotions. That is soon the UGC, they have formed the new education policy. They are going to make it mandatory that any teaching faculty has a PhD. Those who are already there, if they don't have, they have to get the degree. Otherwise, new job offers will be for people with PhD only. Such a thing is there. So you can give the exam, and if you get the job, or see, that exam also gives you a scholarship for a PhD. Okay, net exam will either give you an associate a lecturer's job in a university or any college. Everywhere, if you have that score, it is very good. But you can also register for PhD because that will give you scholarship. Is it not, sir?
Yes. Okay, thank you, Vijay. Any others?
I am Dharmendra Singh.
Hello, ma'am.
From
Yes.
ARC Vijay Library. Can I be audible?
No, talk
I
slightly.
am Dharmendra Singh from BARC. YJ Library. is research career in number theory and cryptology in defense and ISRO, and tell about research career opportunity after PhD and postdoc completed at age 40 plus. Now I am not PhD also. I am only B.Sc.
See, cryptology and all are not, see, all these DRDO labs don't, some of the DRDO labs don't work on cryptology, etc. or cryptography. But there are places like BITS Pilani and all, even in those days, they had an MSc mathematics where they offered cryptography as one of the core subjects many years back. See, even if you do that, there may not be any direct relevance to the work in a DRDO lab, most of the labs, or even ISRO labs.
Okay, thank you.
Sir, am I audible?
Hello, ma'am.
Yes.
I am Anusha from Kerala. Ma'am, can you hear me?
Yes.
I am Anusha from Kerala Maths Aspirants Group. The class was very informative. Thank you for giving us various information. Can you tell me about how we can join actuarial science? About the entrance exams?
See, there is no entrance exam. I have given the name of the society where they conduct the classes and conduct the exams. There are some professional bodies who conduct the exams, who maybe give you some notes or they conduct classes and you have to give the exam. That is how it is. You cannot take up a job and then start learning actuarial science, right? So your mathematics and statistics will help you to learn it very fast. Because they are basically looking at probability, risk factor. All those are low probability or high probability. All these come down to basically all your mathematics and statistics only. How you are going to apply it there. So with your mathematics and statistics background, if you register in one of the societies, you can easily do an initial course and later become a fellow also. So most of the time, these professional bodies themselves have a campus selection. Because not too many people go for actuarial science.
Okay, thank you, ma'am.
Welcome.
Hello, ma'am.
Yes.
Am I audible?
Yes.
I'm Gayatri. I have studied in Miranda House College, Delhi. First of all, it was a great session, ma'am, and you have shared a lot of information that we never heard, and it was very useful. Thank you for spending your valuable time with us, and I'm really thankful to Vinod sir for conducting this session. And thank you, sir. Thank you, ma'am.
Welcome, ma'am. Welcome. Most welcome. It was a pleasure for me to address people because I do a lot of mentoring here also. If people don't know what to do, how to go about things, we see what is their field of interest and passion, then you can slowly take them up. See, for example, I'm for a MSc Maths students last time. See, everybody after a post-graduation, you need a job, So I said, okay, you get a data science job, do the job. Next 2 years, you will know what is your that you are liking then the job, what is also the market requirement. Based on that, you do a post-graduation. Is it not? So you also will be happy, you will also be financially rewarded. Everything you need, So we generally tell people to take up a job after a post-graduation if they are not immediately not sure of what PhD they want to do. After 1 or 2 years of a job, they will have better clarity on what they want to specialize.
Hi, ma'am. Am I audible?
Yes.
Hi, ma'am. Good afternoon, ma'am. I'm Harit from Kerala, Mathoma College, Chungatra. It was a wonderful session. It is a honor for us to be with you for this past 2 hours. And thank you so much for all your efforts and time you spent with us. And thank you so much, Vinod sir, for such a wonderful opportunity for all of us. And I'm also part of our group, Maths Aspirants, and I'm preparing to jump with Vinod sir and our team. I have something to ask you. You have been completed your higher education a far time before all we have even born. So, what was your experience in achieving such a higher education in that time, and what would be your advices for the younger generation as who wish to become higher positions in mathematics?
See, fortunately for me, I was at Institute of Mathematical Sciences, which was under the Department of Atomic Energy. We had a wonderful library, and I had my Science Talent Scholarship and contingency grant. And if things are not here, we had access to IIT Library, Madras IIT Library. We could also go to the Department of Mathematics in the university, which is called Ramanujam Institute for Advanced Study in Mathematics. So it was a grand time learning new things and getting your results. And every year we used to have a symposium where we had to make presentations. So you get used to making papers, presentations, all those things. And all those, we don't generally do up to MSc, right? All those are learning experiences. Is it okay, Harita?
Thank you, ma'am.
Okay, welcome.
It's great pleasure to know that you are still learning, and you are very happy to say that at this age also you are most pleasurable in learning new things, and it's a wonderful experience and an inspiration for younger generation like us.
Oh, thank you. Thank you so much. Thank you so much.
Thank you, Harita.
Hi, ma'am. Good afternoon.
Good afternoon.
Respected teacher.
Yes, son.
Hello, ma'am.
Ma'am, I would like to thank you for conducting such a good session. It has been very informative one, and the information you have shared was very rare one. We have not been aware of the application of mathematics in aircraft. It was interesting one. Thank you, ma'am, for sparing your time to taking such a wonderful session. Thank you.
Thank you. If all of you have learned something new, have heard about some more applications and job opportunities, I'm very happy that it has helped you, given you more information, right? Lots more information in general, and also especially applications in aircraft design, testing, flight testing, everything.
Thank you, Annie. Any others?
Ma'am, I am
Yes.
Anamika from
Good
Kerala, Guralpan College, Kozhikode. Thank you, ma'am, for the nice session. And this session was wonderful, and you cemented our concept that maths have a field everywhere in our life, and everything is maths. You cemented that concept now. And I have something to ask, that you mentioned about MTTS, and you said that we can send email to them to participate with them. And is there any format we should maintain when we email them?
No, you can ask them for general functioning of MTTS and what they do, etc. They will send you. Or you can, to know about MTTS, you have to internet, no? Mathematics Training and Center, that MTTS website is there. They tell you lots of things that what they are doing. And any additional information you want, you can send a mail to them. And website itself gives you the email.
Okay, ma'am, and we can understand how much effort you put upon this, all things to teach us and to guide us. And thank you for that, for everything you did today. Thank you, ma'am, and thank you, sir, for this nice session and wonderful session you arranged for us.
Thank you. Thank you so much, Anamika. Thank you so much.
Thank you, Anamika. Any others?
Hi, ma'am. Good afternoon, respected teacher.
Yeah.
Yes, yes.
Ma'am, I am Manu from Jean, Haryana. I have just passed my master's in mathematics. First of all, thank you so much for this fruitful webinar. I want to become financially stable as well as continue my study. How should I get to know about opportunities? Can you help me for this?
First, yeah. What all subjects you have learned in your MSc Maths? Is it a pure Maths or applied Maths or a combination?
Mathematics.
No, in mathematics, what all you have learned? Only pure mathematics, topology, function analysis, etc. You have learned partial differential equation, tensor analysis.
Yes, functional analysis,
And then
analysis, real analysis.
Complex analysis, higher algebra, all those you have done, but these are all coming under the pure mathematics side. Anything on application, applied mathematics or applicable mathematics? Anything you have done, any papers?
Yes, ma'am. I have done.
What have you done? You have done some paper on fluid dynamics? No.
No, ma'am.
Then what you have done? Artificial intelligence, AI and ML, machine learning?
No, ma'am. We have done just subjects like functional analysis, linear algebra. Yes.
Then topology.
Yes,
Then
ma'am.
you have learned
Topology.
differential geometry, topology, and then?
No, ma'am.
No,
Differential
but you have 4
geometry to
semesters, each semester. Huh?
What, ma'am?
No, but you would
4
have studied
semesters,
more.
ma'am.
Yeah, 4 semesters. Each semester you will have how many papers? 3 papers? So 3 into 4, 12 papers, no? Minimum 3, no? 3 4 credit courses you will have, right?
Yes, ma'am.
What else you studied? No, I am trying to see what you can plan to do. Also something that you should like the subject, no?
Ma'am, I like the subject. I like teaching. Then what? But just I just want to improve my confidence level in teaching. I have never teach a student, or I just want to increase my self confidence.
See, confidence will automatically come when you know the subject well, right? When you are very thorough with the subject, you won't have any problem as far as confidence is concerned. You are teaching the students, you are teaching the right thing, you are prepared, you are teaching. They don't know it, they learn what you teach. So if you are very thorough with the subject, there is no problem for confidence. You don't worry about communication. Mathematics, we don't worry much about talking English or Hindi. Okay, communication thoda upar niche doesn't matter. That's what I'm trying to tell you. But subject thoroughness has to be there, is it not?
Okay, ma'am. Ma'am,
Okay,
how
you
can
have
I
tried for some
know
jobs?
about the
You have tried
opportunity? Ma'am, I have
You can
given
go into the
resume for
internet.
in schools. No, ma'am.
Colleges?
No, ma'am. I have just given resume in schools.
Schools. But, school teaching is fine, but you should probably go to a higher level now. You have done your post-graduation, right? MSc, right?
Yes, ma'am. I have done my post-graduation. Yes, ma'am. But I have never not cleared the NET exam for college
Okay,
level
I was
teaching.
about to
I
ask you, have you
need
tried?
to clear the
Why don't you
exam.
prepare and give the NET exam again? You get some school teaching, okay, but try to prepare well and give the NET exam.
Ma'am,
every year it is there, no?
I will give this
Isn't it?
exam, and I am preparing for this.
Okay, thank you, Manu. Arjuna, we are running short of time. You can move to the other parts.
Okay, sir.
Arjuna?
Yes, sir. Good.
Now that we have a short of time, we can really assume that the session was awesome, because still they have doubts to ask and it's not finished. But there is no option. We need to consider the time also. So so I must really say that thanks to Indira ma'am is beyond words. But as a formal meeting, I like to call Kajal for delivering a vote of thanks on behalf of everyone here and Maths aspirants. Welcome, Kajal.
Thank you, Arjuna. So first of all, happy Independence Day to one and all. I'm delighted and grateful to be part of organizing team and got the chance to express my thankfulness on this occasion. Firstly, thanks to Aparna ma'am for brief introduction of today's speaker. Dr. Indira Narayanaswamy ma'am gave a highly inspiring talk about the opportunities and challenges of pursuing a successful career in mathematics. Her thoughts was a very great blessing to us today. Honestly speaking, Everyone believes that earning a degree in mathematics solely qualifies one for a profession as a teacher. However, it is quite amazing how you have influenced participants' opinions, ma'am. You told us about different programs under running in reputed institutions, financial assistance for higher studies, and application of mathematics, statistics, training internship program, also about defense-related work and material. Really a very motivational, inspiring, and a great lecture. On behalf of every participant, thank you so much, ma'am, for sharing your experience with us and educated us on the complexity of mathematics. Additionally, I would like to thank the entire organizing committee, Dr. Vinod Kumar sir, Associate Professor of Mathematics, TM Government College, Kerala, Dr. Bijumon sir, Associate Professor of Mathematics, MG College, Kerala, Ms. Zia Rose Johnson, Research Fellow, IIT Madras, and Ms. Ananme Tone, Research Fellow, CEOSAT, Kerala, for such a fantastic event and for providing excellent coordination throughout the program. Also, thanks to Arjuna for such a great welcome and hosting the event. Last but not the least, a big thank you to everyone who came and contributed to making this webinar engaging and interactive. I want to express my gratitude to all of you for making this occasion a grand success. Thank you all for joining us. Thank you so much.
Thank you.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव